can you tell me what you know about periodicity?
Okay, so periodicity is like these are the chemical properties of element, depend upon the electronic configuration, and the yeah, that's it. Okay.
Okay.
They are the chemical properties of elements depend upon the electronic configurations.
Okay, so you gave an idea about uh, on what aspect my periodicity depends. Okay, when I ask you periodicity, it
Hmm.
is just the period of or classification of elements according to some property, not just chemical property. It can be any physical or chemical property. Okay, so periodicity means the regular period of arrangement of elements. So now periodicity is just regular arrangement of uh, if I am talking about periodicity of elements, then it is regular arrangement of element. Periodicity can be in atoms also. Say for example, if I am talking about a crystal, okay, if I am taking some, so periodicity is just the term as regular arrangement. Periodicity can be in any form. It can be in your atoms, it can be element, it can be your ions. So anything, okay. But now here I am specifically targeting periodicity in elements. That means regular arrangement in elements. Now this regular arrangement in elements can be based on due to some properties. I'm not highlighting or differentiating physical or chemical. Clear?
Hmm.
Okay, cool. So now we are talking about periodicity in properties or periodicity of elements in terms of properties. So we'll be talking about periodic table. I hope you have seen the modern periodic table. Okay.
Yes.
So how many elements do we have in the periodic table?
118.
118 elements. Cool. Okay. So now, can you tell me, you are seeing this periodic table, no? So
Yes.
can you tell me what are the 4 blocks in the periodic table?
S subshell, P subshell, D subshell, F subshell.
Okay. So since I am asking you block,
Oh, sorry,
so
sorry,
uh,
block. S block, P block, D block, and F block.
F block. Okay. Why you should not say subshell?
Subshell is it's like the subshell. I mistakenly said that
Uh,
it's like
so
this subshell.
if I ask you the principal quantum number or subshell, then you can say, okay, these are subshell. So which are the S block in this periodic table?
S block is the first two periods.
Okay.
Yeah, and then the rest from 3 to 12, they are the P block.
No, they are the D block.
Right.
Correct.
What is? Yeah, right.
And then
And then the last two ones are the F block.
so
Not
these two last
Platinum.
one which are kept separate. This is F block and
And the P block is 3 to 18.
13 to 18. Okay.
Yeah.
So 1 to 2, 3 to 12 is D, 13 to 18 is the P block element. Correct?
Yes.
Okay. Now, what is the general name for the S block elements?
What do you mean, ma'am?
Do we call some name for S block element? Do we?
These what do you say? S block element. There's a name for it, like the halogens and those things.
Very good. So, but halogen is which group? Okay,
Halogen.
one more thing you tell me. Our periodic table is divided into how many periods and how many groups?
So there are basically 17 periods.
Sorry.
There are 18 groups and 7 periods. 18
Yeah.
groups.
Okay, correct. 18 groups and 7 periods. So I was asking you what is the common name that we call for S block elements. Do you know?
Alkaline.
Like one of the group of S block is alkali. So the first group, like this particular first group, the red one is called as alkali. Okay. And the yellow one,
The yellow one. No. It's basic. Oh, what am I? Second one. I'm not sure, ma'am.
it's
Earth
okay.
metals. Yeah, earth metals. Earth metals.
Alkaline earth metal. It's a
Like,
part of like alkali only. Okay,
yeah.
so it's alkaline earth metal, not that very strong alkali. So I hope you know why these are called as alkali metals. But
Yeah.
okay, do you know correct why they are called? So do you know the combination of alkali and alkaline earth metals also has a common name?
They have a common name. More common name.
So these
No.
are called as the S block elements are called as normal or representative elements.
Oh.
Okay. Okay. Now, what is the common name for D block elements?
D block elements. They are the transition metals.
Very good. So these are called sorry. So these are called as the transition elements. What is P block element?
Now this P block element, these are like there are post transition metals and there is reactive non-metals. There is like there are noble gases and
Okay.
there are yeah.
Yeah. So there is no such defined like name for the P block elements. So these are basically called as non-metals, but they do also have metals and non-metals and metalloids also. Okay.
Yes.
So there is no such specific name for P block element, but there is a common name for F block element. Do you know that one?
F block element. These are the reactive non-metals
No,
or
no, no.
lanthanoids.
Lanthanides and actinides is again the separate, like the first light pink that you are seeing, that is the lanthanide.
Hmm.
Okay. And the green one that you are seeing, these are called as actinide. Like S block element, alkali and alkaline group has a common name, which is normal elements or representative elements. Similarly, lanthanides and actinides combination is also given as a common name. Do you know what?
No.
So basically, these lanthanides and actinides are actually emerging out from the two transition elements. Okay,
Hmm.
and their F subshell has to be filled before like d orbitals. So these are called as inner transition elements. Okay, the lanthanide and actinide combination is called as inner transition elements. Okay. I was just taking this like periodic table because I just wanted to know how much you know in that. Okay, so that then we can understand the periodicity or periodic properties. Okay, cool. So, and also I'll just tell you, like, if I am taking future classes and if you are interested to continue with the class, you don't need to write anything. I'll basically write everything on the slides, and after each class I will share the slides also. Everyday class resource you will get, okay, from Udemy app. So you don't need to write, you need to understand only the as much as you can grasp from the class. See, I will also ask you to write when we are doing some problems. Okay, that point I'll ask you to write and you solve it. Otherwise, you don't need to write that much. I don't want to make it as a school class so that you have pressure of writing also, understanding also. That is the sole reason of this one-to-one session, so that you just understand fully, concentrate on the slide and grasp as much as we are discussing. Okay, cool. Yeah. So now we will switch to the concept of, so this is the common idea about the periodic table, how many elements are there. So now they have, see, this is the modern periodic table. So this modern periodic table was obtained after several versions, correct?
Yes.
So do you have an idea about all those versions? How does this concept came up?
It was won by Mosley, right?
It was by Mosley. And Mosley used the concept of Mendeleev. Okay. Now you tell me, this modern periodic table is arranged, has caused the arrangement of these elements, which is based on what property? So you said electronic configuration, but how does the Mosley define the periodic table? What did he say about the modern periodic table? Like I am asking, like how the elements were classified into different periods and different groups based on what
It was
periodic.
it was based on atomic numbers, right?
Very good. It was based on atomic number. Okay. And what do you understand by atomic number?
Atomic number is the or how do I say it? It's the number of the element. It's like the, how do I say it?
What it is equal to?
Atomic mass is equal to its mass.
No, I'm talking about atomic number.
Um, it's a nuclear charge.
Okay. Okay, no issues. So I'll tell you. Okay. So there is, one is atomic number, one is atomic mass, and one is nuclear charge. Okay. So now, I'll just brief. I won't take much, but I'll just brief you. So we have atom, where the central part, the rigid part of that atom is the nucleus. Okay. Which contains neutron and proton. Proton are the positively charged particle. Neutron are the negatively charged particles. So there are protons and there are neutrons in nucleus. Okay. So the summation of protons and neutrons is equal to atomic mass. Okay. So your atomic mass is represented by A, and this is equal to neutrons and protons. Okay. And the the combination of protons and neutron is actually called as the nuclear charge. Okay. Combination of protons and neutrons is called as nuclear charge. So atomic number is actually equal to
Number
the
of electrons.
number of protons, or you can say as number of electrons.
Electrons.
Okay, fine. So now your periodic table, modern periodic table, has been classified based on the atomic number. Okay, an atomic number is nothing but it is equal to the number of electrons and number of protons. So number of electron is something that is being considered for electronic configuration. That is what you were telling, that okay, my modern periodic table is being arranged in terms of their electronic configuration. Okay. So electronic configuration is what? It is the arrangement of electrons in different shells and subshells. Okay. The way electrons are arranged in different shells and subshells for different elements will have different arrangement, and based on that arrangement they have been arranged into different periods and groups. Okay. An atomic number is represented by symbol Z. Like atomic mass was represented by A, so atomic number is represented by Z. Okay, clear. Now we are going, so my periodic table is there, but there was, like, scientists were doing some experiments and they were trying to understand several physical and chemical properties. Okay, so you know that the chemical property of any element will depend on what? What is the factor on which your chemical property of element depends? Chemical or physical property, I can say. Not physical, but chemical property will depend.
The size of the electron, size of the atom,
Size of the atom.
yeah, and then the charge of the atom, and
What is
then the
the size? What is
binding
the
capacity.
what
Sorry,
is the size of the atom?
size of the atom is atomic radius, and there's ionic radius, and there's covalent radius, from which we
Okay. To some extent, I say okay. Atomic radius size is actually you can say like 2 pi r, like peripheral radius, like periphery of like radius. Okay, size or something. So
okay.
it's not actually the size of atom which decides. That is why different versions of periodic table came up. See, the first periodic table was based on atomic mass, which got not satisfied because there were many elements which were not arranged according to their isotopes were not placed properly. Correct? Then there were physical properties like atomic volume and other properties were there because of so so the I'm just giving you an idea that there were different things like you are saying atomic size, okay, you are saying atomic charge, whatever. So all these concepts were not able to define the periodicity in the properties properly. There is only one concept which can define the chemical or the physical properties of any element. And what is that? You yourself said that periodicity depends on electronic configuration. So it
Yes.
is my electrons which will actually determine the any of the chemical property of the element. Okay, because if I'm not talking about electrons, I'm not going to talk about any kind of bonding also. Any element will form a bond with the other element only and only when my electrons participate in bonding. Correct? Whether it has to be ionic bond, it has to be covalent bond, it has to be coordinate bond, hydrogen bond, any kind of bonding. If I am talking about, my electrons are going to take part. Correct? Any kind of chemical reactions in chemistry you are going to talk about, it will be the electrons which will participate. So my all periodicity in properties of all the elements will be depending on one factor, that is the arrangement of electrons. That arrangement of electrons will actually tell you what is the size of your atom, what is the charge of the atom. Okay. So the first property that we will discuss its trend for the periodicity in properties is the atomic radii. Okay. Now you tell me what you understand for the atomic radii. I think this has cut. My maybe actually, what happened earlier, I used to make my slides in other like laptop. So my laptop got crashed little bit yesterday. So they have installed a different window. Okay, like Microsoft Office. So that is the problem. Okay. Yeah, I don't know how to. It's okay. I'll share you the correct slides. Don't worry for that.
No, no,
Okay.
yeah.
Yeah. So okay. So what do you understand from atomic radii?
So atomic radius is the distance from the center of nucleus of the atom to the outermost shell of the atom.
Very good.
Sorry, of the electron.
Of the electron. So you can say outermost valence shell electron. I think it is not. I think you lost your network.
Ma'am?
Or did I lost my network? I don't know. It's see, I am able to see from my this thing. Just give me a minute, no?
Yes. I can see a slide.
You can see my slides, no?
Yes, ma'am.
Okay, okay, okay. 1 minute. So you said it's the distance between from the center of the nuclei to the outermost valence electron, I can say. Okay. So it's distance between nucleus and outermost electron. Right. Now you tell me, so I can say this as R, okay, atomic radii. Now you tell me, do you think how can we measure atomic radii?
So there are technically like there are three types of atomic radius. There's like a covalent radius, metallic radius, and van der Waals radius. So each of
Okay.
them have, sorry,
No, no, yeah, fine. Say atomic covalent radius, metallic radius,
and van der Waals radius.
and van der Waals radius. Okay, yeah. So, uh, so how do we find atomic radii? With the help of covalent radius, metallic radius, and van der Waals radius?
With the with the internuclear distance between the two bonded atoms.
Yeah,
That is,
okay. So, what is covalent radius?
covalent radius is the half of internuclear distance. Internuclear distance between the two atoms, bonded atoms.
Okay, cool. So, you said that it is the distance, half of the distance between the two internuclei radius will give you the covalent radius. So, covalent radius is also the part of the atomic radius. So,
Yes.
and how do you calculate the metallic radius?
Metallic radius, it is the one half of the internuclear distance, separating the metal cores in the in the metal crystal.
Okay, cool. And what is van der Waals radii?
Van der Waals radii is the one half distance between the nuclei between the nuclei of two identical non-bounded isolated atoms.
For example,
It is used in noble gases.
van der Waals radii will only be present in the noble gases,
Yeah, it is used in in noble gases.
not any other.
I'm not sure.
See, there can be any element which will be non-bonded. Say, for example, my copper will not form a bond with nickel. So then, in that case, also there will be distance there. See, van der Waals radii is basically there are two atoms which are non-bonded, but they are close enough to each other so that you can calculate their internuclear distance. Okay.
Mm.
So my concept for asking all this thing was that atomic radii is a very small distance. Correct. It's
Yes.
actually in picometers. Correct.
Yeah. Mm.
And it is very difficult to calculate this atomic radii by any kind of the technique. So in order to calculate atomic radii, I should know the internuclear distance between any bond. Okay. And that's why this covalent bonding, ionic bonding, and all these concepts come up. So now we have to say, for example, like I just giving an example, like for example, for C2, okay, the metallic radii is given as 256. Then what will be its atomic radii?
Atomic radii would be half of this.
Yes. So this is basically Cu2 atoms. So it is the internuclear distance. So metallic radii, actually, metallic radii, or you can say atomic radii for Cu2 will be the half of the 256 picometer. So this is basically the internuclear distance. Okay. So now, so why I have to study the atomic radii and as a periodicity? Okay, because you are telling that atomic radii is the distance between nucleus and electrons. Again, my electron is coming into picture, and that too as the outermost electron, correct? So once electron is playing here an important role, that means my like in periodic table, the electrons arrangement is going different. So atomic radii will also be different for the elements that are arranged in the periodic table. True? Correct?
Yeah.
So, so that is why there is observed a certain trend in the your atomic radii for the elements. And that trend we need to study here for the periodicity of elements. Okay. So you understood, no, why this is a periodic property? Because it involves the electron, and your full periodic table is based on the electronic arrangement of electrons only. So there is a trend, particular trend followed for the atomic radii also. And every like property trend we have to understand across the period and the vertical columns. Okay. So what will be like when we move from left to right in a period, how my atomic radii is changing, whether it will increase or decrease. And the same thing we need to study for the group also. So what do you think the atomic radii trend will be when I move from left to right? What's happening?
It will increase.
No, it will not increase across a period. Okay, so I'll make you understand now this thing. See,
Oh, right.
yeah. Okay, so say you have nucleus and you have electron. Okay, fine. So now what is happening? This is your atomic radii. Fine. So so your atomic radii is dependent on two things. One is the nuclear charge and the other is the size. Size means number of shells.
Yeah.
So what will happen if your nuclear charge is more? Means the positive charge around the nuclear, positive charge present on the nucleus is more. The electrons will be attracted more towards the nucleus. Okay. So your size will reduce. Make sense or not? I'm talking
Yes.
like if I am increasing positive charge in the nucleus, then suppose if I have to talk about only one electron, then this will be attracted more towards the nucleus. So your size of the atom will get reduced and reduced. Okay. See, whatever you are talking about shells and subshells, these are basically not definite shells and subshells. They are actually the energy cloud. Okay, electron cloud. So now so 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 you understood, like my if my nuclear charge is increasing, there will be more attraction and size will reduce. Okay. And now the second part is number of shells. So suppose I have the same nucleus and now I have 3 shells. So the more the shells are there, the distance of the outermost electron from the nucleus will increase. So that will cause the increase in the atomic radii. Correct? So now when I move from left to right in a period, you will see. So when I move from left to right in a period, say for example, 1, 2, 3, 4, 5. Say one is hydrogen, helium, lithium, beryllium, boron. Okay. So now their electronic configuration is 1, 2, 2 comma 1, 2 comma 2, and 2 comma 3. Okay. So for this, I'm going from left to right in a period. So you are seeing that the nuclear charge is equal to the protons plus neutrons. Okay. It's actually the number of protons present in the nucleus that is equal to the nuclear charge. Okay. So now for this, when I'm going from left to right, my nuclear charge is increasing. It is 1, 2, 3, 4, 5. Okay. But number of shells is same. It's all are having, this is having 1, but this is having 1. This is having 2 shells. This is having 2 and this is having 2. So, so what will happen? Your number of shells is not increasing that much, but your number of nuclear charge is increasing more. Okay. So since your nuclear charge is increasing more and number of shells is remaining same, so the attraction of the outermost electron for this one will be more as compared to this one, compared to this and this and this. So attraction is more because nuclear charge is increasing from left to right. So your atomic radii will reduce from left to right.
Okay.
Okay. But for example, if I'm taking, say, hydrogen, lithium in a group, sodium, potassium, okay. So this is having 1, 3, 11, 19. Okay. So I will have 1 shell here, then 2 and 1, then 2, 8, 1, then 2, 8, 8, 1. Okay. So what is happening in down the group, my apart from nuclear charge increasing, but the outermost shell, I am talking about the nuclear charge on the outermost shell. So here it is 1 shell, here it is 2, here it is 3, here it is 4. So along with the nuclear charge, my shells are also increasing. And the more the shell size, like number of like higher shells is increasing, their distance from the nucleus will increase. Okay. So the effective charge from the nucleus that will apply on the outermost shell will get reduced. Okay. So down the group, because the number of shells are increasing subsequently, my nuclear charge acting on the outermost electron will be less. Hence, your atomic radii will decrease. So along the period, atomic radii will increase down the group. Okay. Along the period, Z effective is called as nuclear charge. Okay. Z effective is more, number of shells is not more, you can say same. So your atomic radii, I can say R, will decrease. Okay. I can also tell you that your atomic radii is directly proportional to Z effective. Atomic radii is inversely proportional to N, where N is number of shells.
Okay.
Okay. So down the group, it increases. Say for example, if you can see these two plots. Okay. So this is the atomic number. Okay. So we'll do one thing. I'll stop as part of demo here. Okay. And I'll just stop here and I will ask your I just want to ask your inputs, like how did you like the class and what are your thoughts on that? Okay. Yeah.
So I basically like the class. It is really your teaching is really good. It's really effective. Yeah. Yeah. It was overall. It was very nice. I did
Okay.
understand many things. Like before, I actually got confused in some things. Like some many concepts were like confusing to me, like Z effective, and then that one. So the meanings got confused within it. So like, yeah, now I understood very well.
Okay, yeah. If you wanted to continue, so you do you want to inform me now, or do you want to inform tuition people, like about the classes? Like, how do you want?
Yeah, I'll
You
tell
want
my dad to inform them.
Okay. I just wanted to tell you, like, what are the if suppose you are continuing the classes, what are the days you are free? Like,
I'm free actually on all the days. Like not that kind of free, but then like after school I'm free.
okay,
I have homework or something, but then I'm free after that. I can
okay,
join class.
yeah. Uh, do you want to take like class on Saturday and Sunday? Is that okay for you?
It's okay. It's fine for me.
Okay, cool. So if you wanted to continue, like you can just like you can let them know tuition, and Saturdays and Sundays, like you can tell me anytime after. See, I'm from India, so you know there is a time difference of Indian and
Mm.
Dubai time of 1.5 hour. So
Yeah.
I'll give you like my 11 is like your will be after your 10 a.m. Anytime on Saturday and Sundays. But
Mm.
before like say your night, I can say
Yeah. You. Everyone wants to be free on weekends. So yeah, I'll do it in the like morning itself. We'll finish it off.
yeah. Means like around 2 to 3 or something
Mm.
like that before
Mm.
7 p.m. Okay,
Yeah.
7
Yeah.
p.m. Okay, then you just talk to tuition people and just let me know. I'll be happy to take it up. Any other requirements from your side? See, I do take questions also. Don't worry for that. And
Mm.
I am free to take up. See, you said like you are preparing for NEET. If see, I can take up from my side some practice papers also. But if you have from your side and if you will let me know that, ma'am, I want to practice for this thing, I'll take it that one. Okay.
Okay.
I'm very friendly. You don't have to hesitate. I'll share guides, everything. So you don't worry for that. Cool.
Yeah.
Okay.
Yes. Good.
You just need to be chill and take up maximum that we discuss in the class. My goal is that only.
Yeah. Sometimes like my problem is like I will understand at that moment, like in class, I'll understand every single thing. But after that, my head, my head, everything goes fades off. I would tell that take tests for me regularly. Like he's a bit strict on me, so like I don't forget the concepts again and again.
You don't worry for that. My pattern of thing is the next day I'll ask you the summary of the class before I start everything, and I practice it. So my one slide for every second class is the first slide is summary of the last class. So that
Hmm.
I'll ask you from you some highlights, and I'll put that I'll add up on my the things that you will not say, and that will be just 10 minutes. So to
Hmm.
brush up your previous thing, so that is
Yes.
my concept. Like
Hmm.
I think you can ask from tuition. Most of my students are satisfied with my way of teaching because that is the thing. I know that you people have lot many subjects to
Hmm.
practice, and you don't get time for every subject that can be
Hmm.
practiced. So I try to get it done maximum in the class. But again, you said that you keep on forgetting. So that is because, but you have to still do some practice also. I think
Right.
that
Right.
will do it. Okay. But I told you, like, first, I always take the summary of the previous class. So that is one thing. Okay. I'm telling. Anyways, once you come up, you will see like how, if you, you will see like how I'm doing the things. And as part of test, once one chapter is completed in
Hmm.
detail, whatever is, I take immediately the test of that. Okay.
Good. Yeah.
Okay. Okay then. Yeah. Just update to tuition. Okay.
Yes, I will do that.
Okay then. Bye. See
Bye,
you.
ma'am. Thank you, ma'am.
Yeah. Thank you.